A into x equal to b, this is called as a coefficient term, this is called as an unknown, this is called as a constant. Earlier there was L and L here. By decomposing, the lower triangular matrix can be eliminated on both sides of the equation. Hello everyone, it is Dr. Ravikumar YB, the Department of Computer Science, Vidhyaashram, First Grade College, Mysuru, the Temple of Excellence. In the previous session, I have taught you about the GAUSS-JORDAN elimination method, in which you have seen as to how the lower triangular matrix and the upper triangular matrix are made as 0, and the transformation to keep the principal diagonal elements as 1, that is transformation to the form of unitary matrix is done, so that on the constants of the same equation indicates the values of unknowns. That means if there is a case with x, y, z, x, y, z, x, y, z. Let me call this as 1, 2, 3. 1, 2, 3. 1, 2, 3. The constants which is written on this side is considered as C1, C2, C3. By making these elements as 0 and these elements as 0 and keeping these items or elements of a matrix as 1 makes the system unitary. By making this system unitary, the corresponding elements which is there in the constant side, that is Z3 equal to C3, Y2 equal to C2, X1 equal to C1, gives the values of these unknowns X1, X2 and X3. The unknowns X1, X2 and X3 are C1, C2 and C3 respectively. The same concept is applied here. That is the thing we have LU decomposition. What is the meaning of LU stands for here? L stands for lower triangular matrix. U stands for upper triangular matrix. These lower triangular and upper triangular matrix together formed in place of A into X equal to C. Here we have A, which is a matrix, that is coefficients. These are called as, this is called as a coefficient. What is this? This is called as an unknown which needs to be determined. What is this? This is a constant. Constant terms. So we have the coefficients A. In place of A, let me replace with LU X equal to C. That is A into X equal to C. In place of A, I have LU here. So we have this operation here. By doing this LU operation, I will find out the values of unknowns, that is X, Y and Z. If that is the case, you shall see that we have A into X equal to B. This is called as a coefficient term. This is called as an unknown. This is called as a constant. So we have these terms. The same thing is explained in terms of this description. That is, LU decomposition method is a kind of exact solution of system of linear algebraic equations. This method attempts to decompose coefficient matrix, that is this coefficient matrix or LU, into two lower and upper triangular matrices. That is, this coefficient term is going to be transformed into lower and upper triangular matrix. Assume that the main system of algebraic equation can be written as follows. That is the same thing. A into x equal to C. After LU decomposition, the system of algebraic equation is transformed to the following form. That is LU into x equal to C. That is LU into x equal to C. What is that L here? C here. C contains L. That is the lower triangular matrix. Then what is that value D indicates here? I have decomposed the upper triangular matrix to get the lower triangular matrix. That is, as a result of which I am getting L and D. So what is that indicates? Where L into U is equal to A. I have already explained you that in place of A, I have LU here, and L into D is equal to B. That is the same thing. In case of C, I have L into C here. That is this operation. By decomposing the upper triangular matrix, I will be left with the lower triangular matrix. Along with that, few constant terms are obtained. If that is the case, let me take you into the details of it in the next slide. See here, this corresponds to the lower triangular matrix, wherein you have the non-zero elements in this section. Whereas these are called as zeros here in case of this lower triangular matrix. Next, in the upper triangular matrix, we have the non-zero items in the upper triangular matrix and zero terms in the lower triangular matrix. That is, we have a combination of L and U. If I place this non-zero terms here, that becomes a matrix A. If I bring this zeros, that is, or to this non-zero items to here, this makes it a coefficient matrix A. So the combination of this is defined as A. We have the terms A1, A11, A12, so on up to A1n. Then A21, A22, so on up to A2n. Similarly, A3, A4, A5, so on up to AN1. AN1, AN2, so on up to ANN. We have. These are called as an unknowns. That is X1, X2, X3, so on up to Xn we have. What is this B indicates? We have B1, B2, B3, so on up to Bn. All these are constants, constant terms. Constant terms. So, by combining lower with upper triangular matrix, I will get A here. So, if that is the case, the vice versa of that, I can obtain L and U from A. L and U from A. Next, it can be seen that L is a lower triangular matrix and U is an upper triangular matrix, as I have already discussed with you all. After decomposition, L can be eliminated from both sides of the equation. Then the main equation can be written as follows. That is, earlier there was L and L here. By decomposing, the lower triangular matrix can be eliminated on both sides of the equation. That is, then it is called as a balanced. We are left with U and X with D. Then what is an upper triangular matrix indicates? Because upper triangular matrix, the solution can be easily found by back substitution as follows. How can I find out the elimination method? As you all have already seen that in the Gauss elimination method, that is, suppose x1 y1 z1 is equal to c1, x2 y2 z2 c2, x3 y3 z3 c3. We have these terms, that is zero terms. Obviously, by making these terms as zero, we will be left with these terms, that is the upper triangular matrix. We will be left with the upper triangular matrix. This upper triangular matrix defines the value of z, that is this term, which is equal to this. I have got a z here, value of z here, which shall be back substituted into this equation to get the value of this. So, by back substituting these two terms into this equation, I will get the value of this. That is x1 equal to c1, y2 is equal to c2, z3 equal to c3. That is the value we are going to get in case of Gauss elimination method. The same thing is applied here in case of LU decomposition. That is lower and upper triangular matrix decomposition. That is, observe here xn equal to dn. I have the range of unknowns, that is x1, y1, z1, that is x2, y2, x1, y2, z3. These are unknowns that is available on the principal diagonal. Then what is dn then? dn is the set of constants we have here. If that is the case, xn is equal to dn. Let me rewrite this term dn in terms of this. If that is the case, I need to expand this equation. If this is called as equation 1 and this is called as equation 2, how can I write down the equation 3, which is in expanded form? That is dn, where I is equal to, in place of n, I have I here. Let me call the value of I is equal to n minus 1, n minus 2, n minus 3, n minus 4, so on up to 1. That means what? Suppose if there are 3 unknowns, then I will state that u3 j. What is the value of j? That is j is equal to 3. u3 3 x3 is equal to d3. Or else, if I bring this d3 to this side, this becomes minus d3. Or else, if I bring this term towards this side, d3 minus u3 3 x3. That is the term we are left with. Well, then what is left with here? We are left with x3, or I will say that it is xi here, because I have 3 here. Let me call this as the expanded version of this for one of the equation. For another equation, let me call this as u22 y2 is equal to d2. If I bring this term towards this side, what happens? d2 minus u22 y2, which is assigned to y term. Then let me call this as another equation, that is second, third, fourth, and one more equation I need to write, that is 1 1, that is for this equation. For this equation, how can I write down that? u11 x1 is equal to d1. If that is the case, if I bring this term towards this side, what happens? d1 minus u11 x1, that is assigned to what? X term. So this becomes my another equation. So suppose if there are 3 unknowns, I will be obtaining with 3 more equations, that is 3, 4 and 5. Suppose if there are 4 unknowns, then I will be having one more equation, that is d4, that is or u44 z4 is equal to d4. If I further simplify this, And if I bring these terms towards this side, what happens? D4 minus U44 Z4 is assigned to Z. So this becomes my next equation, that is equation 6. So how many unknowns are there in this case? We have the unknowns X, Y, Z. Already I have a Z here, and one more, let me call this as P. These are the unknowns I have, that is unknowns. These values must be determined. If that is the case, the same thing is explained here. The same thing which I explained in the previous slide, that is this, is explained here. Multiplying L's rows by U's columns, L and U matrices can be determined from the following relations. If that is the case, Ln is equal to An, where I is equal to 1 to n. If that is the case, let me consider U1j is equal to A1j divided by L11, comma j is equal to 2 to n. I have the values ranging from this, where U is equal to U of 1, j is what? 2. 1, 2. U12. U12, that is U12 is equal to A12 divided by L11. Next, U13 is equal to A13 divided by L11. That is this term, for this term. Suppose if there is one more term, that is this term. If there are three unknowns, so let me have this. Similarly, for j is equal to 2 to n minus 1, do these steps, that is 1 and 2. 1 and 2 steps must be followed. If j is equal to 2, yes, of course, j is 2. What is the value of j? 3. In this case, it is 2 and it is 3. Follow these steps. That is, which is that step? Step 1 indicates that is Lij is equal to Aij minus summation of Liku kj, that is where I is equal to j, that means the principal diagonal elements, to n. That is, please observe this carefully now. I have I and j is equal to, are equal. When I is equal to 1, j is equal to 1. When I is equal to 2, j is equal to 2. When I is equal to 3, j is equal to 3. So if that is the case, I can write down this equation as a balanced equation in terms of this. If that is the case, let me write down this as L11, that is this term. L11 is equal to A11 minus summation of 1k. What is the value of k here? Please observe this carefully here. I am also using the value of k here. What is the value of k here? K is equal to 1. 1 to j minus 1. What is the value of j here? It is 1 here. J minus 1 means what? What is the value of j here? L 1 U 1 it is 3, it is 1 2, n minus 1 or 1 minus 3, that is this 3 plus L12 U12 is combined together. This entire thing is represented as summation k is equal to 1 to n minus 1 or j minus 1 here. J minus 1 where Lik U kj, because the number of columns of this must be equal to number of rows of this term. So then it is called as the operations of multiplication is possible, L and U. So as a result of that, I will be left with this term, that is this L and U are possible to do that. If that is the case, if you look at it, you will see that these and these terms are same. If that is the case, what has to be this? This must be 3 1. L13 star U31 plus L12 star U21. This is okay. This is correct. This is not correct. This is okay because the terms are same here. K and K. K and K are correct. This is for step 1. For step 2, when I come to step 2, I have UKJ, that is the upper triangular matrix. How can I define the upper triangular matrix? Step 1 defines the lower triangular matrix, that is LIJ. Step 2 defines the upper triangular matrix, that is UJK. UJK, which can be obtained by bringing this term down to this. How can I do that? That is, the same thing is done here. If that is the case, UJK is equal to summation of K is equal to 1 to J minus 1 LJIUIK divided by ILJJ, where K is equal to J plus 1 to N. If that is the case, I will be left with the upper triangular matrix. How can I define that upper triangular matrix? That is where J is equal to what? Let me have some values. Where K is equal to what? Let me have some values ranging from K is equal to 1 to J minus 1. Where K is equal to J plus 1. That means what? If J is equal to 1, 1 plus 1, it is 2. That means K is equal to 2. K is equal to 2. Then when J is equal to 2, K is equal to 2 plus 1, that is 3. That is 3. K is equal to 3. It becomes 3 then. So that is how it is going to compute to get the upper triangular matrix elements. Then ultimately, as a result of which, I will be left with a matrix which is of this form, that is ANN minus summation of K is equal to 1 to N which is equal to 1. That is the principal diagonal elements. LNK into UKN, because the terms are equal here, to make the multiplication possible with L and U. As a result of which, we will be left with the lower triangular matrix which gets decomposed. I know that there is a mathematical equations, and of course it is very interesting to learn these mathematical equations, because any research papers or any high-level mathematical operations that is done that requires the mathematical equations like this, without these they will not consider. That is the reason I am expressing all these information in terms of mathematics. Then I will move on to the examples, wherein you will see the different types of problems which can be solved with the help of LU decomposition, that is lower and upper triangular matrix decomposition. With this, I am going to conclude that the LU decomposition can be calculated in terms of the coefficient matrix A, that is the coefficient as a vice versa. Then the matrix A, that is containing the coefficient terms, can be transformed into the lower and upper triangular matrix, as a result of which we will be decomposing the lower triangular matrix to get the upper triangular matrix, that is by elimination, then by back substitution, as a result of which we will be left with the values of unknowns. Thank you very much. Thank you one and all. If there is any questions, kindly come back to me in the live sessions once again. And in this regard, I want to tell you one more information, that is the examples of LU decomposition will be explained in the next and subsequent classes with an example. Thank you very much. Thank you one and all.